I would like to present more examples of the shell method. So let's take a look at our first example. This first example, I already have everything drawn out for us. I'm just going to walk through the procedure and hopefully explain the reasoning behind how you use the shell method. So for our first example, we've got the line y equals 2x, the line y equals 1/2 x, and the line x equals 1. And we want to rotate that region about the y-axis. So this is a very generic example. You can see that I've got this line y equals 1/2 x drawn here, the line y equals 2x drawn here, and x equals 1. That is creating this triangular shaped region, or this triangle. And we want to revolve it about the y-axis. Because everything's already in terms of x, it lends itself to this shell method. Because we know that if you're going to revolve something about the y-axis, in general, you want it in terms of y, so you'd want dy's. But because everything's already solved for me, I've got everything in terms of x, this lends itself to the shell method. And so the shell method says we want to take the volume, which would be equal to 2 pi, the integral. Now I have to decide when to start and when to end the integral. That's dictated by this region. It's telling me to start at x equals 0 and end at x equals 1. So I wrote the integral from x equals 0 to x equals 1. The next part is your radius. The radius has to be determined from your axis of revolution. So if I am on the y-axis, if I were to move to the right, I'm moving an undisclosed amount to the right, that would be your x value. And then once I move to the right, this takes me to my height, and the height would be the 2x minus the 1/2 x, and you can see that's what I have here. So here's my radius. I've got 2 pi radius, and then the height is determined as the 2x minus the 1/2 x, that vertical distance. And then dx, because with the shell method, it's always the reverse of what you were expecting. It's telling me that each one of the shells that you would create has a width that is infinitesimally small. So it'd be dx. Now to calculate this, I'm not doing any of the integrals by hand. I'm cheating. I'm letting the calculator do all the work. So I'm going to go to my calculator here. And as you can see, I'm going to type in 2 pi times parenthesis the x times parenthesis 2x minus 0.5x, or minus 1/2 x. I hit the graph button. I'll do my second calc and do option 7. Whoop, I don't think it took the second. Second calc, option 7. So it's asking for lower limit and upper limit. I want to start at 0, which is my lower limit, and I want to end at 1. And you can see that that gave me a value of 3.1415, which happens to be pi. So it gives me the area of pi. That's our first example. It's a traditional example of how to use the shell method.